Welcome to Think Global Education Services. Today's topic will be uniform circular motion. Consider an object moving in a circular path. For instance, let's take an object here at position A, and the mass of this object is m. Now it is going to revolve around an object here, and its mass is capital M. It is going to go in this path, and it travels from A to position B. Now it has covered a distance of theta, that is, it's covered an angle theta. So this angle, it has covered a angular distance which is s, and the angle is theta, so it has covered an angular displacement. That is the angular displacement of an object with mass small m is theta, and theta has a unit of radians. And let us consider this circle as a radius of r. And as we know, using the length of the arc formula, we can write the length of the arc S is equal to radius of the arc multiplied by the angle theta. Here theta is the angular displacement. Now angular velocity is the rate of change of angular displacement. So angular velocity is represented by the letter omega, which is equal to d theta by dt. And theta has an unit of radians, so you can write radians divided by unit of time is seconds, radians by seconds. And next is angular acceleration, which is represented by the letter alpha, which is d omega by dt. So d omega has a unit of radians per second divided by second, so it will be equal to the unit of angular acceleration is radians per second square. The next concept would be using this formula, we can write ds by dt, that is, when we differentiate the length of the arc with respect to t, we will get r d theta by dt. So ds by dt, which is nothing but here s is the angular, that is the length of the arc, so there is a displacement of arc, so that then we will get velocity, that is displacement, rate of change of displacement is velocity, which is equal to r, and d theta by dt is omega, r omega. So v is equal to r omega. Here this v is the velocity of the particle which is in this direction, and since velocity is a vector quantity, we can represent it as vector, and this velocity is tangential to the path of this circle, that is the tangential to the circle, tangential to the path of the particle as well as tangential to the circular path. Yes, and here the velocity will be in this direction as it is tangential to the circle. So the next part would be, if the angular acceleration is constant, if alpha is constant, then we can rewrite the equations of motion. As you can see, we can write the equations of motion for circular motion using the equations of motion for linear motion. So that is, we have to change a certain values and we'll get the equation of motion for circular motion. As we know that in case of a translational or linear motion or even a parabolic motion, you will get the equation of motion which is equal to S equal to ut plus half at squared. Similarly here, instead of S you will get theta. Instead of ut you will get omega naught t plus omega naught will be the initial angular velocity plus half a, instead of a you will get alpha t squared. And next part would be v is equal to u plus at. Now here we can rewrite that as omega is equal to omega naught plus alpha t. Similarly, the third equation of motion will be, that is here, v squared is equal to u squared plus 2as. You can rewrite that as omega squared is equal to omega naught squared plus 2 alpha theta. So these are the equations of motion if, in case the alpha is constant, in case the angular acceleration is constant. So in a uniform circular motion, we can say that the angular acceleration is constant. So thereby we can write the equations of motion for an object which travels in a uniform circular path. That is a circular path. And here, since the object travels in a circular path, we can say that the force on the object is directed towards the center. And this force is called as the centripetal force. Centripetal force. And we can find out what is the centripetal forces. That is, using the value of A, we can derive the value for A. A is the acceleration of the particle at this position, A, and acceleration of the particle at the position B. If you find out the acceleration will be equal to v squared divided by r. And by using Newton's second law, F equal to ma, and find out F is equal to mv squared by r. And substituting the value for v, we can also get the acceleration in another form. V is equal to r omega. From this equation we can substitute it here. So you will get r squared omega squared divided by r, which is equal to r omega. So these are the identities that we need to know in case if you want to solve any problems based upon circular motions. Yes. And also we can derive what is called as the tangential acceleration. That is the tangential acceleration. Acceleration is tangential to the path. It is the acceleration of any mass which is at this position or at this position or anywhere on the cycle. And you want to find out what is the acceleration. The acceleration will be pointing towards this side if the object is here, and in case the object is at this position, the acceleration will point this side, and in case the object is here, the acceleration must point here. So we can find out the tangential acceleration using these values. As we know that v is equal to r omega, so if we further differentiate this equation, it is dv by dt. We're differentiating with respect to time, we'll get r is a constant value because the radius is a constant value. We'll get d omega by dt. d by dt is a is equal to r multiplied by d omega by dt is, here it is, alpha. This is another identity, and here this acceleration is called as the tangential acceleration. And this tangential acceleration is useful in finding the centripetal force. and thank you for watching.